right, here we go, y'all. So, question for you. We've done 2 labs in this class, salt and sand and density. And guys, when I handed you those labs, what is the very first thing I always encourage you to do? Scan through it, get a sense of what's going on. Well, guys, let's do the same thing here. And guys, you'll notice that different and yet similar, not like our labs, although our labs are hyper organized. Guys, this is organized too. You have no idea what any of these words mean. But guys, just by glancing at the paper, your eye should go, there's organization to this. Can you talk at all about the organization? Actually do this. Talk to the person next to you about the organization. How is this structured?
It's very simple.
So in a second, Tyler, you're going to get up here and you're going to tell everybody?
Yeah.
I like it. I like it.
Maybe it's
Koya, what's this? I like it, whatever it is. Guys, you got about 10 seconds. All right. So guys, coming back together, I'd like to point out to you that if you're not seeing the organization to this, you have big issues because Tyler said it's simple.
yeah.
Sorry, I couldn't resist. So guys, I love the way you're talking about this. I see Koya doing this because she realizes there's something vertical. I heard a couple of you, good on you, actually, reading, sorry, I'll pull it up too. Guys, I heard some of you going, wait, there's general and specific and ordered and disordered, and you actually saw that the organization at some level was laid out for you. But guys, did your eye also catch this? That we've got subsets of subsets of subsets. Did your eye catch that? I see Chris nodding. Guys, the idea is that as we move from top to bottom, we're breaking things out. We've got matter, then 2 types, then 2 types of homogeneous, then 2 types of substances. But guys, the organization goes the other way as well. Elements and compounds are substances. Substances are homogeneous, and homogeneous is matter. And so guys, there's organization to this. And we are going to track this down by talking about the organization. Now guys, here's the deal. This is the only slide that you're going to see today. All of the notes are going to be on this page. But guys, it gets a little tight. So what I would encourage you to do is not only take notes, but put them on your paper where I do, and then I promise you it will all fit. Okay, so guys, the first thing we need to do is we need to do a little doctoring up. See this line right here? Do you see why that line is stupid? If you understand the organization, you do, because guys, this says heterogeneous materials. You don't even know what that means. But how many kinds of heterogeneous material are there? Only one. See, there's 2 kinds of homogeneous, but there's only 1 kind of heterogeneous, so these have to be the same. So let's get rid of the line. I know that made no sense at all. It will. Then guys, this. Down at the bottom of the table. Guys, this is your goal for today. I underlined them just to not make a mess. You may want to circle them, up to you. Guys, this is your goal for today. You will know that you've been successful today if you can think and talk intelligently about elements, compounds, solutions, and heterogeneous mixtures. So guys, what we're going to do is we're going to start at the bottom and we're going to start talking about these things. But as we do, we need lenses, right? In the same way in biology, if you want to study cells, you've got to have lenses to see the cells. Well, guys, in this class, we need lenses to talk about these things, but our lenses are not physical lenses. They're concepts. Guys, notice where this goes in the upper left-hand corner of your paper. These are your lenses. Chemical properties, and physical properties. So guys, just blindly write them down right now. And then I'm going to show you one of my favorite things about being a chemistry teacher. It's not the ethanol. I'm glad that you understood that. Some days it might be the ethanol, but no, I'm just kidding. All right, you guys okay? Not quite. Do this. As you're writing these down, would you please underline the words new and no new, not new, no new, 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 no. So new and not new and no new. It sounds really stupid if you say it a lot. No new, no new, no new, no new. Do you ever get to the point where you're so tired you just find yourself babbling?
Yes.
Chris, on the other hand, claims he's well rested. I have to admit, I don't believe you. You're a high school student at the end of the week. It doesn't happen.
I got 14. Yeah, not 14. 12 hours of sleep.
How many classes did you miss?
0.
Liar.
20 minutes.
Seriously? You guys are amazing, or just really tired. Yeah, but if you're like my daughter, go to bed and put your phone down are two completely different things. Okay, fair enough. All right, so guys, let's talk about what this means. So as we think about physical and chemical, as we think about elements, compound solutions, and heterogeneous mixtures, the way that we're going to understand them is by their physical and chemical properties. Physical properties, no new substance. Chemical properties, new substance. So you guys ready to have your lives changed? Paper. Wait for it. I know. I know. Paper, guys, tears. I know. Physical or chemical property? Physical, because this is still paper and this is still paper. And consequently, we can observe that without creating something new. Ready for another life changer? Paper also crumples. I know. Physical or chemical? Physical, because it's still paper. But now, guys, I get to do this because I'm teaching chemistry. And you guys are strangely fascinated with fire. Me. So, guys, paper burns. Okay. I know. So, guys, let's talk. This is what we technically like to call ash. Is it paper? No. The smoke in the air, is that paper? No. Is there smoke and ash trapped inside of paper and we just have to let it out by lighting it on fire? No. So have we made something new?
Yeah.
So paper burns, physical or chemical? Hey, now we understand. So guys, now that we understand those ideas, we are going to use them as our goggles through which we are going to understand elements, compound solutions, and heterogeneous mixtures. Grab your periodic tables. Hey, these are also organized, right? But guys, how are these organized? There's one overarching organizational structure. Do you see it? Numbers. And guys, those numbers go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, done. Guys, you should know, but I understand that junior high school is an academic wasteland, so you've forgotten. What do those numbers mean? Do any of you know? Close. If you had stopped at first, you would have been right. Christian. Which means what? That's it. Charles got it. Guys, these numbers mean the number of protons. Check it out. Hydrogen's got 1. Helium's got 2. Lithium's got 3. Beryllium's got 4. Guys, we live in this magic universe. And you are going to find as time goes on that I stand in awe of this world in this universe. Guys, this place is crazy amazing. And one of the things to me that makes it crazy amazing is that if you add a proton to an atom, it becomes a new atom. Look at element number 82. What is element number 82? Lead. Guys, it looks like this. This is lead. Inside of lead, there is nothing but lead. So guys, every single atom that is inside this sheet of lead has got 82 protons. Now you want to talk about something crazy. If we could grab those lead atoms and if we could remove 2 protons from each one, what's it turn into? Really? Oh, 3. What if we remove 3? Gold. Guys, that's it. If we take lead and remove 3 protons from the atoms, it magically turns into gold. And we can do that. It's wicked expensive, so it's cheaper to just dig it up. But guys, we live in a universe where the identity of elements is simply based on the number of stinking protons. That to me is pretty cool. So, guys, keep looking at the periodic table. So I've got a question for you. You'll notice on the periodic table that we've got black, red, blue, and outline. Christian, you've proven an ability to look at the key, so look down at the key. Tell us what those colors mean.
Black is solid.
Boom. Yep. And outline is? Synthetically prepared. So guys, let's talk. Looking at your periodic table from a distance, the vast majority of the elements are solid, liquid, or gas. Most of them are solids. Where are the gases? On the top and the right, with except for hydrogen, which is over on the left. How many liquids are there? Dose. They are mercury and bromine. And then guys, this. What does the outline bit mean? And guys, the outline bit means that these elements would not exist in this universe if there weren't humans. Guys, all the elements at the bottom of the periodic table that are in outline only exist in research labs in Europe and California. And where? Oh yeah, and actually 43, and thank you. Guys, 43 is a tricky dude. It's called technetium. And the thing that's interesting is that we actually can find technetium in the earth. So guys, every other one of these elements we can dig up somewhere. But guys, it turns out that technetium, we do find a little bit of it, but it's so trace that we just call it man-made. Isn't that true? Do you know? I think that's true. Do you know for sure? Shoot. Guys, by the way, this is Ruth. You're probably, are you going to go by Ruth? Yeah. So guys, Ruth is a chemistry education major over at BYU, and she's going to be hanging out with us. She's not student teaching. She's way earlier in her academic path, but she's going to be hanging out with us, and she's way smarter than me. And so guys, if you ever need help, talk to her. I don't know what I'm talking about. So, all right. So then guys, this, ready? Do you got to go? See you. I look forward to it. So guys, this then, what is the heaviest element on the periodic table that we didn't make? Uranium. And guys, this is actually uranium. This stuff is stupid radioactive. This is, and you should know, this is not pure uranium. This is what uranium looks like when we dig it out of the ground. It's trapped in rocks. This actually came from Moab. So guys, have you all been to Moab? And you know how when you're driving into town, right at the river, as you're coming in from the north and you look to the right, you look to the west, and there's that big cleared field that has security fence all the way around it? That used to be a uranium mine. And during World War II, we were so hungry to get uranium because we really wanted to end the war and we needed bombs. And so guys, we were digging up uranium everywhere we could find it, including this, which is from Moab. But then when the war ended, we decided plutonium was a better explosive, and we didn't care as much about uranium, and they just walked away from the mine. Guys, that entire area is actually a hazardous waste site that they're spending millions of dollars to clean up because of this stuff. So this is uranium. All right. So, oh, I hate that thing. What's that? What'd you say? No? Okay. All right. So later. And when did this happen? Are we back? We're back. Okay. So guys, here's where we're at. So we understand this is lead, 82 protons. We understand that this is uranium, 92 protons. So guys, the idea is this. These are elements. Elements are made of the same atom. So guys, that is our definition of an element. It contains one type of atom. Write it down where it goes down here. One type of atom. All right. So now, guys, we need to get your eyes accustomed to the dark a little bit. You'll see why. But guys, we're going to go look at another element. Element number 11. I know it's dark, but can you still see it? What's element number 11? Sodium. Guys, allow me to introduce you to sodium. Guys, sodium looks like this. This is a stolen picture, so there's the source on it. But guys, this is sodium. Here's what I'd like you to do. Flip your paper over, and on the back, please write down 2 physical properties of sodium, physical properties that you can see from this picture. And by the way, that thing on the right is a knife. I like it. There's actually a better term for that, though, and we'll talk. So guys, 2 properties, physical, of sodium. How you guys doing? You got 2? You okay? Brady, give us 1. Good. And can I add another layer to that? Guys, Brady said it's a solid. Let's say this, it's a solid at room temperature. Because guys, you understand there's nothing on the planet we can't melt, and there's nothing on the planet we can't turn into a gas. So you can actually turn that into a gas. But at room temperature, it's a solid. Let's go, Ivy, give us another one. Yeah, it's like gray or silver or whatever you want to call that. Guys, it might have been Bittner. It sounded Guy and Backish. Someone said soft. Was that you, Christian? So yes, how do you know it's soft? Yeah, like literally you can cut it with a butter knife. So guys, sodium is very soft. There's a technical term for that. It's called malleable, but it's very, very soft. So guys, all of these are great ideas. All of these are physical properties. But now guys, grab your periodic tables. Should I turn the lights back on for a minute? Can you see? Guys, grab your periodic tables and do this. What is the density of sodium? 968. So guys, think about this. The density of sodium is 0.968. Is that a physical or a chemical property? Physical, because we know it and we don't have to change the sodium. But guys, check this out. What does that tell you about sodium in water? It floats. It is less dense, 0.968. It floats. But guys, it doesn't stop there. Check this out. So what we have here is this. This is a beaker of water. And then, guys, we are going to draw, another chemistry teacher, is going to drop, they took all my sodium away, by the way, when we built the new school. Guys, he's going to drop a piece of sodium into the water, and will it float or sink? Floats, but it doesn't stop there.
Sodium metal in?
Whoa. Guys, sodium doesn't just float, it bursts into flames. When we put it in water, what's actually happening is the sodium metal is ripping the water apart, hydrogen gas is given off, and it's hot enough that it bursts into flames. Yeah. Say that again. It's not did you say salt? That's brilliant. Oh my gosh. Can you hold that for just a second? Because guess where we're going to go with this in about 2 minutes. Yeah, right? That's brilliant. Hold that thought. So guys, what do we now know about sodium? It's flammable, physical or chemical property. Oh man, because guys, we got heat, we got smoke, we got crazy. That's a chemical property. Do you now understand the difference? Okay, now do this. Guys, go to, where's my pointer thingy? Go to element number 17. What do you got? Chlorine. Solid, liquid, or gas? Solid, it's a gas because it's red. But guys, let me introduce you to chlorine. So guys, physical properties. Chlorine is a gas. That's physical. Give me another physical property. Green? Yellow, green? Okay, we're trying to come up with a color. Could we agree that it's mustard colored? All right. You don't have a choice. We're agreeing. So guys, the deal is this. You guys know right now there are rogue nations, there are established nations, crazy but established. The guys right now have stockpiles of chemical weapons that they're not only using on their enemies, they're using them on their own citizens. But guys, understand that the United States holds the distinct honor of being the first country to use chemical weapons against hostile enemies. We went there first. World War I. Guys, you've all seen the pictures of the Civil War where men in uniform with a flag and a drummer would walk out onto a field. They would stand face to face. They would lower their weapons. Somebody would say fire and just this, right? Guys, war now looks like a video game. We've got drones in the air. We're blowing up places in the Middle East, and the guys that are flying and ladies that are flying these things are in air-conditioned spaces in Las Vegas. You guys understand this, right? Okay. World War I was different. We figured out that civil war, hey guys, go shoot each other, wasn't a great way to win a war. But we didn't have the drones, so what did they do? Guys, what did war look like in World War I? You dug pits. And you guys have probably all heard the stories about, I think it was the British and the Germans and Christmas, and they called a truce, and they all came out and they sang Christmas carols and they played soccer. And then after that, they went back in their holes and started killing each other the next day, right? Well, guys, do you also understand that not most, but a lot of, again, men, because this was World War I, because a lot of the men that died in World War I didn't die because they got shot. They died because they got sick, living in a pit in the middle of winter where they went to the bathroom down there. They were wet. They died of illness. So guys, the United States figured out, we got to figure out a way to kill people if they're smart enough to not stick up their heads so we can shoot them. So we said, we need something that can go down in the pit and kill them for us. And then we thought, what could do that? And we said, all right, we could make these bombs and we could launch them out of a cannon and they would land on the enemy fields. And then when they blew up, they would release chlorine gas. But we didn't call it chlorine gas. What did we call it? Mustard gas. And this mustard gas is less dense than air. And as it spread out across the field, it would then settle into the pits. And guys, these men had no choice but breathe it. And when you inhale chlorine gas, it gets into your moist lungs and it turns into hydrochloric acid. And it literally eats your lungs from inside out. It's a horrible way to die. But guys, now what do we know about chlorine gas? Well, chlorine gas reacts with water to turn into hydrochloric acid, which we've used to kill people. Is that a physical or a chemical property? Chemical. All right. So now, guys, let's talk about what we know. We have sodium, which is a shiny, soft, solid at room temperature, and it bursts into flames in water. And then, guys, we've got chlorine gas, which is yellow, which is a gas, not green, mustard, yellow. And, guys, it reacts with water to form hydrochloric acid, which is bad. Well, guys, guess what I've got right here? Yeah, right? Guys, this is table salt. And it seems from the Salt and Sand Lab, some of you didn't know this. But guys, in here is a shiny, explosive metal and a yellow, deadly gas. But guys, we throw this on our food every single day, and we eat it, and we like it. So here's the trick. What happened? How did sodium and chlorine turn into this? And those are your words. Don't write them down yet, Charles. But guys, what I'd like to do is I'd like to show you how this happens. And it goes like this. Let's write down the words first and then I'll show you. Guys, Charles got this exactly right. We have formed what is called a compound. And guys, compounds are two or more atoms bonded together. But guys, let's look at what this looks like when it happens. Y'all set? All right, here we go. Setting the stage.
This is one of my favorite experiments. Supposing you want some fresh salt. None of that stale old store-bought stuff. You want the fresh stuff. You got to make it yourself. Well, how are you going to do that? Salt?
All right, guys, here's our players. What's that? Sodium. In here is chlorine gas contained in a container because it's a gas. And then over here we have popcorn.
Is sodium chloride. Sodium is a metal that explodes on contact with water.
We knew that.
And chlorine is a deadly poison gas. They actually used it in World War I as a poison
We knew that. But now, guys, watch this.
gas.
All right, so here's what we've got. Over here is the chlorine being pumped through a tube into this crucible, crucible. And then, guys, in there we've got sodium, and he's using a torch to start the reaction. When that happens, the sodium metal reacts with the chlorine gas. Watch close.
But if you take a book.
All right. Now the reaction is started. So, guys, look at all the smoke that's coming off of this. Physical or chemical change? Chemical. But you ready for this? What's the smoke made of? Table salt. Guys, that smoke is pure table salt. But guys, y'all see where this is headed, right? This is the popcorn in a nylon fishing net.
Full of molten sodium, and you blow pure chlorine gas into it. You get a fire, and the smoke coming off of that is pure salt. So we hung some popcorn over it, salt popcorn with nice fresh salt. And it worked great. We got some good shots that we used in the magazine. Then turns out,
what's going to happen? Heat and nylon.
the net started melting, and it actually dropped the popcorn into the molten sodium. Sodium exploded, and we got popcorn and sodium flying everywhere. That's really not such a bad thing.
That seems like a bad thing to me.
You know, it tells you that science doesn't always go the way it's supposed to. It tells you why it's important to wear a face shield and have all the right safety equipment. And it made some really good shots that we could use also.
All right.
This is one of my favorite experiments.
Guys,
Supposing you want some
good on these two ideas. Elements, one type of atom the whole way through. Compounds, atoms bonded together to form something new. You guys good? Okay, now let's go up. Guys, these are both substances. Remember, these are organized. Guys, these are both what we call substances. Substances have unique physical and chemical properties. Nothing is like lead. Nothing is like gold. Nothing is like sodium. Nothing is like chlorine. But guys, salt isn't like sodium, and it's not like chlorine. It is also a substance. So substances, guys, are simply things that have unique physical and chemical properties. So this then brings us to a division. Guys, draw in this line. And then we've got this. Over on the left-hand side of this line, everything is unique. You guys know what unique means, right? Not like anything else. But guys, on the right, we've got stuff that is not unique. So this is going to sound weird, but hear me out. Guys, you will notice that there are two kinds of matter that are not unique. What do they have in common? They are both, well, certainly materials, but they are both mixtures. I would encourage you to circle that. Guys, they are both mixtures. All right, so here we go. So guys, in order to move forward with this then, let's talk about one of these mixtures. And you'll notice that this says this is a homogeneous mixture, but guys, we're never going to call it that. We're going to call it a solution. So you guys ready to have some deep thoughts? Let's see how you're doing so far. Let me get rid of my elements. All right. So guys, here we have sodium chloride, element or compound. Compound because it's not like sodium and it's not like chlorine. Guys, here we have water, H2O, element or compound. It is a compound. Guys, hydrogen, element number 1, is a clear, colorless, explosive gas. Oxygen is a life-supporting, clear, colorless gas, and this is not either one. This is water. It's unique. It's a compound. But now, guys, watch this. We're not going to make a mixture. Add a little salt to the water. Favorite chemistry pencil. Boom, done. So, guys, we just created a mixture. But, guys, here's the deal. What does this look like? Water, what's it taste like? Is it unique? No. So guys, we know, hey, oh shoot, you know what? I actually totally forgot to tell them the bad is mine. I'm going to tell them now and then we will next week.
Oh, this is the last.
Nuh-uh, it goes next week. Doesn't it? Okay, so here's the thing. We're going to do it anyway, and even though we're not in the week so we can't get pizza, we're going to, yes. Yeah, okay. Guys, do you know about this? So LIA, Latinos in Action, you know we have a food pantry? Do you know about that? It's really cool. We have a room in the school that's literally like a mini Walmart. And you can go in there and get food, you can get clothes, you can get school supplies. Because guys, the reality of it is even amongst us, probably there are people that that for a myriad of reasons don't have access to food and clothing and stuff. There are actually people in my ward that have people drop off food to them every week. So we have this. So my bad. I totally forgot. Guys, they're doing a food drive right now to gather food and supplies for the pantry. It's got to be non-perishable. So like canned and boxed foods, clothes, stuff like that. Guys, I'm sorry. I just forgot. If you guys would like to bring stuff to donate to that, do on Tuesday and then we'll take it down. I feel horrible. I forgot to tell you. So guys, back to this. Is salt water, right? Tastes like water, tastes like salt, looks like water. Is it unique? It is not. Therefore, the water and the salt are not bonded together. Did you see that? Guys, the water and the salt are not bonded together. If they did, it would make something new, and this isn't new. This is called a solution. It is a mixture that is not bonded together. And guys, every solution has two parts, and you need to know these terms. We have a solute, and we have a solvent. Guys, the solute is the thing that's being dissolved. The dissolvee, that's the salt. The solvent is the dissolver, that's the water. Can I zoom back out of that? You still writing? Christian, you okay? Okay. So now, guys, organization time again. Do you see how all of this stuff fits under homogeneous? Let's define it. Guys, homogeneous matter is the same stuff the whole way through. So guys, let me show you what we're talking about. Same stuff the whole way through. So what things are homogeneous? Well, guys, elements are homogeneous. That slice of lead is lead the whole way through. Compounds are also homogeneous. Water is water the whole way through. Table salt is table salt the whole way through. But guys, salt water is also homogeneous. Now think about this. Imagine if you could shrink yourself down and swim through the water. What would you run into? Salt water, right? It wouldn't be water, 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 salt, salt, water, water, salt. It would be salt water the whole way through. If you've swam in the ocean, you know that you don't come to these magic places where it's not salty anymore. It's salt water the whole way through, and that makes it homogeneous, and we call those solutions. So guys, homogeneous is the same stuff the whole way through. Groovy? We're almost done. You guys good? Last one. So guys, the last thing we need to talk about then is heterogeneous. Heterogeneous is many types of matter. Now guys, with this, and I'll zoom in for you, there comes some terminology that you need to know. So let me lay them on you. So when we think about heterogeneous materials, guys, these are materials that contain more than one phase. What is a phase? I'm glad you asked. A phase is a physically separate component of a mixture, and I know I'm going fast, but I'll slow down in a minute. And then guys, finally, interfaces are the places where phases come into contact. So we have phases and interfaces in heterogeneous mixtures. So guys, all we have to do to wrap up the day is show you an example of something that's heterogeneous. And then we're going to go all the way to the tippy top of the pyramid, and we're going to define matter. And then you guys are going to get your homework done. And you're not going to have homework this weekend. Yay. Hooray, we're dead. I don't know why it is, but whenever I grab a meter stick, I feel like I need to, and I don't even golf. Well, I do have clubs. But I play like once a year for the joy of that one shot that gets off the ground. It's not pretty. I know, it's that one shot that keeps bringing me back, right? It's usually a par 3. You got the ball up on a tee with an iron, and you just click. And you're like, I can play this game, but I can't. You guys all caught up? Can we do heterogeneous? All right, go Tigers, blue and gold. Tiger blue through and through, me and you, Scooby-Doo. Here we go. All right, so guys, what I've done is in an Erlenmeyer flask, I took some water and I put some food coloring in it, solution, but now you can see the water. And then guys, this is simply cooking oil that looked a lot better before I did this in first period. It got a little foamy, but here we go. So guys, this is an example of a heterogeneous mixture. So let's talk about why. So guys, down here we have the water phase. Why is the water phase on the bottom? It's more dense. And then on top of that, we've got the oil phase, and oil and water do not mix. They don't dissolve, so they're separate. But guys, I would propose to you, and actually this, do you see the interface where the oil and water touch? Now do you understand phases and interface? Okay, so what about this? How many phases are actually in this flask? 1? You know there's at least 2. Maybe 3? I would suggest 5. So guys, look, we've got the water phase, but then you'll notice that between the water phase and the oil phase, this interface is like a scum layer. That's really not oil or water, so that could be another phase. Then we've got the oil phase, then we've got the air phase, and then we've got the stopper phase. So maybe 5, but you can see the interfaces. Heterogeneous? How about now? Can you now see the phases? Can you see the interfaces? Is it still heterogeneous? How do we know? And guys, the answer is one of 2 things. First of all, mentally, imagine that you could shrink yourself down and swim through this. Besides being really nasty, what would you experience? Yeah, globs of oil, right? It would be water, water, oil, water, water, oil, water. It's not homogeneous, not the same the whole way through. But guys, what happens if we let it sit? It separates, right? Guys, what happens if we let salt water sit? Well, if it evaporates, right? That's this Great Salt Lake. But guys, if we could cover this, so like Salt and Sand Lab, if we could cover this so the air doesn't get out, will the salt ever separate? Never. So guys, this is homogeneous, the same thing the whole way through, and it doesn't separate. This is homogeneous, other way. Homogeneous, this is heterogeneous, and can you see it already starting to separate? Do you see the distinction? Okay. One more thing to do and we're done. Let's go all the way to the tippy top of our thing. And guys, the last thing we need to talk about is matter. But guys, you'll notice everything fits underneath. So guys, matter is simply anything that exists. As you learn on the announcements every day, wait for it, you matter. See what I did right there? That's all I got. But guys, really, anything that exists is matter. You ready for a deep question? What do we call the absence of matter?
Space.
Kind of. A vacuum. It's time. So guys, the absence of matter is a vacuum, which we do find in space. So guys, there you have it. What's that? You're done? We're okay? All right, so guys, homework. So guys, again, as I mentioned to you at the beginning of the day, we're kind of in a little bit of like a weird spot. Because what we should do is we should get together next time and we should go into lab and we should make a bunch of compounds and solutions and mixtures and play with centrifuges and do all sorts of stuff. But guys, because of Miss Call's schedule constraints, we are not going to do that. So here's the problem. You are going to have a week to forget all of this. So in order to avoid that, guys, we're going to get this homework done before you leave today. You know the rules. This is student guided time. We are going to work only with the person seated next to us in quiet voices. And guys, the answers to this are on our website. Feel free to grab your phones. Thank you. On our website, feel free to grab your phones. They're also up here on the wall. But guys, this is double-sided. So there's a front and a back. But you guys know to stop before number 2 because that's next time's homework. Again, guys, there's 3 homework assignments in this unit and you got them all. So we're going to do front and back. Guys, please ask questions if you need. We have half an hour. You all should get this done today. That means you're reinforcing the things that you learned. And then guys, when I see you Tuesday, we will grade that. We'll record this. And then guys, you'll get your test back on Tuesday. And we'll just keep going from there. Yeah, Joseph. Yeah. Yes, yes. No, can I give you an example? Air. Air is made of nitrogen, oxygen, helium, all sorts of elements, but they're all mixed together, but they're not bonded together. So, but they are the same the whole way through, right? So you can take those nitrogen, oxygen, there's some helium, and that's a solution. So elements can make mixtures. Yeah, absolutely. All right, y'all. Dig in.